guys, welcome back. This is our lesson, and it's one of my favorite lessons, so take that how you will. We're going to be completing the square in order to solve a quadratic, and then later on in the lesson we're going to use the same technique or similar technique to rewrite a quadratic into a different form. So that's kind of exciting. The first task that we have for ourselves is to create what we call a perfect square trinomial. So the idea for a perfect square trinomial is that when you factor it, it factors into the same set of factors. So like for instance, a perfect square trinomial would be x squared plus 6x plus 9. Because if you went to go factor x squared plus 6x plus 9, you would factor it into x plus 3 times x plus 3, which then we usually would come back and rewrite that as x plus 3 squared. So this is an example of a perfect square trinomial. Why would we want to do that is probably your question. Well, once you can get it to look like this, now it looks like a question, or at least a piece of a question from our last lesson, which was how to take the square root to solve a quadratic. So the act of completing the square is a way for you to rewrite a quadratic equation into a square rooting problem, which I think we can all agree the square rooting lesson was actually kind of amazing and easy. So if possible, and this is actually my favorite method for solving a quadratic, completing the square is kind of amazing. So there's a couple of catches. In order to complete the square, this coefficient right here must be a 1. If it's not a 1, there's ways to get around that, but it does make your math a little more complicated. The way this pattern works, though, is if you can figure out who this middle term is, if you cut that middle term in half and then square it, you have the correct term at the end of the trinomial, and then you can move forward and write it in its factored form. So that's our first task. Can you figure out what number should be at the end of the trinomial, and then can you factor it? So using this formula right here, that's the same thing as what number is going to be placed in place of that c. So here is the b term. In this case, it's a -8. We're supposed to cut it in half, and then we're supposed to square it. Now notice the parentheses, we're squaring the negative as well. So you can type this in your calculator, or you could do a little mental math. -8 cut in half is -4, and then -4 squared, -4 times -4 is going to be a positive 16. So we just found out, it's a lot of arrows, sorry, that this last number is 16. So I'm going to rewrite this as x squared minus 8x and then a plus 16. That's great. That's a perfect square trinomial. So now we can take it one step further and we can factor it. Well, if you tried to just factor this through like your normal factoring methods, this would factor into x minus 4 times x minus 4. So I'm going to rewrite that as x minus 4 squared. And let's talk about why this is actually kind of awesome. Your factoring always follows this pattern. So if you know you've set it up properly, the pattern, the factor will be x, and then whatever half of b was, so this guy right here, half of b, -8 over 2 is -4, and then that quantity squared. So 2 tasks in that problem. Can you figure out what that last number is, and then can you take it one step further and write it in its factored form? Interesting. All right, so this next one, this isn't so great. Our middle term is a -3. Uh-oh. And you're supposed to figure out this. So C, remember same formula, is quantity, -3 cut in half, and then squared. All right, what does that become? Well, I know a lot of you are reaching for your calculator right now. I don't think we need to do that. When you square a fraction, you just square the numerator and the denominator. So -3 squared is 9, and then 2 squared is 4. So this fraction becomes a 9 over 4. And I know you're like, gross, you want me to factor with a fraction? I do, but we're going to use our formula that we just found out works pretty darn nice. All right, so there's your trinomial. That's the first answer. And now we're going to rewrite it in its factored form. I would never have you factor with a fraction in Algebra 2 unless it's completing the square, because we're going to follow this pattern. Remember, the pattern is you take whatever b was and you cut it in half, which you've already done. So -3 over 2, I would just call that -3 over 2. And then quantity squared. Looky there. I bet you didn't wake up this morning thinking, oh, Mrs. Abruzzo is going to make me factor with fractions. Kinda. All right, this next one should be like a piece of cake compared to the last one. Your middle term this time is a positive 26, and your first task is to figure out what this number is right here. So C is found by taking, parentheses here, by taking the 26, it's positive this time, cutting it in two, and then squaring it. So again, you can use your calculator, or some of you have this memorized. 13 squared is 169, so there's the C value. So I can rewrite my trinomial as x squared plus 26x plus 169. I don't have to like really stress over the factoring here, guys. It's not that bad. You just write down the quantity x, and then remember you already figured out what half of b was because you did it up here. Half of b was a plus 13. Just make sure you have the quantity squared at the end, and then you're good. All right, so on each of those questions, you had to do a couple of things for me, so make sure you notate that. They wanted you to find C, rewrite the trinomial with the appropriate value for C, and then come through and factor it. So these things I'm boxing in red and green, they're equivalent to each other. One is the trinomial form and one is the factored form, and you have to be kind of fluid to go between the two of them, right? So now how can we use this to actually solve a quadratic? So this is kind of cool. We're going to take a quadratic that would not be able to be solved through, possibly not be able to solve through another method, and I'm going to force you to solve it through completing the square, which means you get to do the square rooting thing we did in the last lesson. So first step, make sure that your x squared has a coefficient of 1. If it doesn't have a coefficient of 1, you got to divide that number out. Then we're going to rewrite our equation. We're going to manipulate the terms a little bit. We're going to move them around. I'll show you that in a minute. Then we're going to find that b over 2 squared thing. So our last task, this is where I was asking you to find C. Then, once you find C, you're adding it to each side and you're going to be able to factor and solve. Seems like a lot of work. Let's see. All right, step 1, make sure that there's a 1 in front of the x squared. There is. All right, step 2, rearrange your terms. Keep your x terms on the left side. But anything that's not an x, you're going to need to move to the other side. So like right here, I'm going to add the 3 over. All right, since we're rewriting things, and I know you don't have unlimited space, do me another favor. Put a plus blank. And then over on this side, 0 plus 3 is a 3, obviously. But think about math. If I added something to the left side, which we haven't done yet, but we're about to, I have to add it to the right side as well, because that's how you keep equations balanced. So now what goes in that blank? I'm going to change colors on this. I don't want to confuse my readers later. We added 3 over here. Okay, so what goes in that blank, that's that finding the C thing, all right? So C equals, remember the formula was negative b, no, it's the quantity b over 2 squared. So for this question, the b value is this positive 10. Now these being your notes, I think it would be very smart of you to go ahead and write down how you're finding C here. There's nothing worse than taking down notes and then going to look at them like a day or two later and you got no idea where anything came from. All right, so 10 over 2 is 5. 5 squared is 25. All right, so that's what we put in the blanks. And I know you're asking, why? Why did I do that? Because look what we're about to do. You purposely put that 25 right here, so that way this trinomial is now a perfect square trinomial, and you can write it in its factored form. So this becomes x, and then half of b would be a positive 5. Isn't that nice? Now on the right side, 3 plus 25 is 28. Hey, looky there. Now you have a square rooting problem. So what you've done is called you've completed the square. So now you've created a square rooting question, and now it's old skills. We got this. Here we go. We're going to square root both sides. On the left side here, the square and the square root cancel each other out, and you have an x plus 5. Remember from this previous lesson for square rooting, once I square root an equation, my answers are now both positive and negative. So I'm going to write down a positive and negative sign here because I'm going to forget if I don't. And now I got to think about breaking up 28. 28 does break down. It is not a perfect square, but one of our perfect squares is a factor of 28, and that would be the 4. 28 is really 4 times 7. So the square root of 4, oops, I think I used blue on the other lesson. I'll do that again. Except now you can't read it. Okay, that's a 4. Okay, the square root of 4 is a 2. And then the square root of 7 doesn't break down at all. All right, we are one step from being home free. Our last step is going to subtract the 5 from both sides. And this is one of those really weird solution sets where there's like an integer and then an irrational piece, so you don't need to combine them in any way. And you just need to write down x equals, I like to write the -5 first, -5, and then we're both adding and we're subtracting 2 square roots of 7. So that was a lot. So in that one question, we were solving through completing the square, so we had to kind of understand that process. We then had to factor it into a perfect square binomial so we could square root the equation. And then we had to rely on our old knowledge of how do you break down radicals and how do you solve a square root equation when there's an irrational answer set. That was a lot. And frankly, guys, that's kind of as hard as it gets today. I don't know why I started with the hard question, but I did. All right, let's take a look at this next one. Oh my goodness. All right, so the first part is 1. That's good. And they already moved the term over for me, so that's one less step for us. I do have to rewrite it, though, because I have to add these blanks to both sides. I think I've been using blue for the blank. So they already have the 8 over here. And then to keep my equation balanced, I'm going to add a blank over here as well. So now the question is, what goes in the blank? We got to figure that out. So the blank, which we call C, is, remember, half of B. So here's B. So cut that in half and then square it. So, again, calculator or brain, this is -3 squared. This comes out to a 9. So again, I know you're thinking, why am I doing all this work? Because now this can be rewritten as x, and then the factor would be half of b. So here it would be a -3. Quantity squared. And then 8 plus 9, better known as 17. Oh my goodness, math teacher is happy because our next step is going to be to square root both sides. And when I look on the right side of the equation, 17 is not a perfect square and it's prime, so there's no perfect squares inside of it besides a 1, which we don't care about. So there's going to be no reduction on this question. So over here on the left side, you have x minus 3 equals, I'm going to put down the plus or minus right now so I don't forget about the two solutions. Square root of 17 does not break down. So all we have to do on this question is simply move the 3 over by adding it to the other side. So x equals 3, positive 3, plus square root of 17 and minus square root of 17. So I'm going to write it as 1 because I'm lazy. I think you guys have figured that out about me by now. I am lazy, 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 lazy. All right, same stuff. So this time they weren't as nice. They didn't move it around for me, so I have to add the 35 to the other side. So this becomes, oh, and there's a 1 in front. I should have checked for that first. X squared minus 2x plus blank equals, and then we're adding the 35 over plus blank. All right, let's figure out what goes in that blank. Again, I'm writing this stuff down in my notes. Very possible I don't write down C equals and then the formula when I'm practicing this until, maybe once I get comfortable I stop doing that step. But in my notes I write everything down. All right, so we're supposed to take B cut in half. So for us, this is B. And then we're going to square it. So that becomes -1 squared, which is positive 1. All right, here goes. This trinomial is now factorable into that really cool format. It's going to factor into x minus 1 quantity squared. I got the -1 from taking this and cutting it in half. Could also just factor it, I suppose. And then 35 plus 1 will be a 36. Ooh, this is interesting. All right, so my next step, I'm going to square root both sides. Left side just becomes an x minus 1. I'm going to put down the plus or minus right now because I just square rooted an equation, so my solutions are now positive and negative. But look at this, square root of 36, that is a perfect square. The square root of 36 is just a 6, right? This simplifies to a 6. So my final step normally would just be to add the 1 over. But this is the rare exception where now you got to take it further. We have all integer answers. We don't have irrational pieces anymore. So my first answer would be 1 plus 6, better known as 7. And then my other answer is 1 minus 6, better known as negative 5. So there's my two answers. I wrote that really stupid. Oh well. Lazy. I'm not kidding. All right, I'm not going to rewrite that. All right, it bothers me to not rewrite that. I just have this vision of this poor child out there who's looking at my notes like, what? What did she do? All right, so x equals 7 and x equals negative 5. So I'm imagining somebody out there is like, oh, well, would she count me wrong if I just wrote this down right here? I don't know if I count you wrong, but I would call you lazy like in a derogatory way. That's too lazy. Guys, you're better than that. 1 plus 6 and 1 minus 6. You know what those answers are. Okay, so if you get integer answers, please give them to me. Uh-oh. All right, so there's a 1 in front. That's cool. We're going to move the 1 over. And the reason I said uh-oh is because we have fractions, which I know panics everybody. But remember our work with the fraction question before? It's not that bad. It really isn't. All right, let's talk about what that fraction is going to be. So to calculate C, you're going to take this guy, cut in half, this coefficient, so positive 5. We're going to cut it in half, and then we're going to square it. Try not to reach for the calculator because you don't need it. We're just squaring a fraction. So you square the numerator and you square the denominator. This is a 25 over 4. Oops, I didn't put my blank down. Blue. All right. So now is the time where we're supposed to factor. And this is why I don't want you guys simply thinking of this always as a factoring question. I want you really to follow that pattern. The pattern that teaches you how to factor these questions each time is really nice. So you take the x, and then whatever the middle term is, you cut it in half. So what you did over here before you squared it was a plus 5 over 2. I know, that's gross, right? Okay. So here we're adding, and I know some of us don't like to add fractions in our head. I gotcha. But if you had common denominators, this 1 is really the same thing as a 4 over 4. So a 4 over 4 plus 25 over 4 is a 29 over 4. I know you're sweating right now. You're like, oh, this is going to get bad. It's not bad, I promise. We're going to square root both sides. Left side, easy. X plus 5 over 2. Right side, not as easy. First of all, don't forget we have a plus or minus. Now remember, when we had a radical and it was a fraction, a division question, we could break it up. We could say the square root of the numerator and the square root of the denominator. And I'm going to do that because this breaks up into the square root of 29 over the square root of 4, which is the square root of 29, gross, doesn't reduce, just leave it, over 2. Well, that's not bad. And now look at our next step. We're going to subtract this 5 over 2 over. I said that weird, I'm sorry. Okay, this is where it does get a little weird, because there's a whole lot of answers I will accept. X equals, normally we put the negative 5 over 2 first. And then we have this plus or minus, just write it singularly like that, square root of 29 over 2. Those are great answers right there. I love them. But did you notice you have common denominators? So maybe you wrote negative 5 plus and minus the square root of 29, all of it over 2. The reason I wanted to bring up that notation is because of our next lesson. So our next lesson, 2 lessons from now, I think, is the quadratic formula, which is negative b plus or minus square root of b squared minus 4ac all over 2. The quadratic formula was derived from completing the square, so all of your answers kind of start out looking like that, and then you keep reducing, which is kind of fun. I just wanted you to be able to realize, like, oh man, these quadratics can be solved multiple ways, and we're going to get the same answer. So that's coming up. It'll be exciting. Okay, so what if we have a coefficient that's not 1? Well, we said it has to be 1, right? So if I have to get rid of this and make it a 1, I'm going to have to divide everything by a 3. And I mean everything. Now the reason we can do this is because it's an equation, so you can divide both sides and all the terms. If it wasn't an equation, we wouldn't be able to do that. So my new equation is x squared minus 2x minus 4 equals 0. So now we're back to that second step where we're going to move the terms around and leave blank. So I'm going to add the 4 over, and this becomes x squared minus 2x plus blank, right? We need these blanks. Okie dokie, let's find our blanks. What goes in this blank? Remember, it is the b term. Now you have a new b term, so be careful. It's this guy. Negative 2 cut in half, and then squared. So that's negative 1 squared, better known as a 1. Okay, here we go. Time to write it in its factored form, because we completed the square. This is now x minus 1 times another x minus 1, or x minus 1 squared. Oh, sigh of relief here, guys. This is a 5. So I'm kind of thinking ahead. When I go to square root the 5, 5 isn't going to reduce at all, so this is going to be a real nice question as far as work goes, because you don't have a lot of work. You have less work, I'll say that. All right, so we have x minus 1 equals square rooting an equation, so our answers are both positive and negative square root of 5. And then our final step would just be to add this 1 over to the other side. We have a combination of rational and irrational, so we're just going to have to keep them separate. We got 1 plus square root of 5 and 1 minus square root of 5, which of course, lazy Abruzzo just writes like that. So 2 solutions, both of them gross. I know you're wondering why I say this is my favorite lesson. I just like it, I don't know. I'm weird. Okay, so everything here gets divided by a 5. Why am I using blue? That's my C step. I should, hold on. Another lazy trick, if you want to divide everything by 5, you can just do that. So my new quadratic is x squared plus 6x minus 7 equals 0. And now we're going to start moving terms around. So x squared plus 6x plus blank equals, I added the 7 over, and then I'm going to add a blank here as well. So let's talk about what goes in that blank. You're supposed to take your b value, which is positive 6 this time. You're going to cut it in half, and you're going to square it. So that would be 3 squared, better known as 9. That's going to be a weird one. All right, here we go. This factors into x. Why am I using the wrong ink again? X, and then half of b would be plus 3. So x plus 3, quantity squared, equals 16. This is why this one's going to be weird. Our next step is to square root both sides. Left side's fine. That's an x plus 3. Right side, I square rooted in a solution, an equation, so it's positive and negative. Now 16 reduces all the way down to a 4. Square root of 16 is 4. So we got x equals, I'm going to subtract 3 over negative 3 plus and minus 4. If that's your final answer, that's lame. Guys, you're better than this. X equals negative 3 plus 4, better known as 1. And x equals negative 3 minus 4, better known as negative 7. So your 2 solutions are x equals 1 and x equals negative 7. So I reiterate, if you have solutions that come all the way down to integers, I need to see your 2 integers separated, please. If you want, you can just separate every single question all the time. Then you always have a habit of doing that. Okay, so this is a twist on completing the square. We can rewrite a quadratic equation that we would be graphing. So like right now it's in standard form. We can use a modified version of completing the square to write it in vertex form. And this is a really neat trick when you're taking some no calculator questions like on the SAT. This is a good little manipulation trick for algebra. So a couple of rules are going to change. This is your split, right? You don't get to touch the left side at all. So it's just going to say y equals and then y equals again. So don't do anything to the left side. Notice I only wrote down 2 lines because that's how quick we're going to be able to get this one done. Okay, the next thing we're going to do is normally I would, move the 11 away from the other stuff, but my one rule was I can't touch the left side, so I won't be able to subtract 11. Instead, what I'm going to do is I'm going to space the equation out a little bit. I'm going to write x squared minus 8x, and then I'm going to go ahead and put down that blank because we know we're going to complete the square. And then I'm going to kind of shuffle the 11 kind of down the problem a little bit. And this is where it gets weird. Because I can't balance the equation by adding a blank over here, another way to balance the equation would just be to subtract a blank. That's interesting. Because you're like, why would I add it and then subtract it like 2 terms later? They're going to cancel. They're only going to cancel if you simplify it that way. I'll show you what I mean in a second. All right, so C, still going to find C the same way. You're going to take this middle term, this -8. You're going to cut it in half, and then you're going to square it. Ooh, once you get the face out of the way. All right. So C becomes -4 squared is 16. So I'm going to put a 16 here, and then this is a -16. But watch the magic. If I strategically group these 3 terms together and call them something else, simplify them, and then I strategically group these 2 terms together and call them something else and simplify them, I'm going to succeed. Ready? This guy right here becomes the factored form of x, and then half of that would be -4, quantity squared, and then 11 minus 16, better known as, I should do a different color here, just to really mess with everyone. That's a -5. Ta-da! You're done. You are now in vertex form. Your vertex is very clearly at the ordered pair for -5. So if you didn't have a graphing calculator and they were like, I need you to find the maximum or the minimum of the quadratic, completing the square is kind of a smooth technique. I'm not going to say we use it all the time, but it's neat. And I know half of this seems made up to you right now because you're like, you just made that up. No, it's just following the rules of algebra. All right, same idea. We're going to have 2 lines and we're going to be done. So this is what I call modified completing the square. So I'm going to rewrite it with a little bit of blanks and spaces. So plus blank. I'm going to keep the -3 there. And then to keep it balanced, instead of adding another blank to the opposite side, I'm just going to subtract that same blank on the same side. So let's figure out what goes in the blank real fast. Same way we always find the blank is you take this middle term, you cut it in half, +14 cut in half, and then squared. So that would be 7 squared, which is 49. So we're adding 49, and then 2 terms later, we're subtracting 49. But it's going to work because we're going to strategically group these together. And we're going to strategically group these together. And what do we have? We have the quantity x plus 7, when I cut that b value in half, squared. And then -3 minus 49 is a -52. That's a weird one. So this particular quadratic has a vertex, now it's in vertex form, has a vertex at, careful, -7, -52. And this is by no means the only way you can find the vertex of a quadratic without a calculator, but it's kind of neat. Again, I think I'm partial to completing the square just because I've used it so much in my math career, because it does come up a lot in advanced math. It's just a really cool manipulation technique. And I already kind of answered that last question. If we have access to a graphing, oh no I didn't. If we have access to a graphing calculator, how can we use technology to help with this problem? So if this question came up on one of my tests or on the SAT and you actually had a graphing calculator because you were allowed to have it at that time, how could we use that to help us out? Well, we could have just graphed this. We can graph it in y equals, like the original one. And we could go find the vertex using the minimum or the maximum feature. So in this case, it would be a up-opening parabola, so you'd find the minimum. And guess what? You'd find out that you have a minimum at -7, -52. And if you knew enough about vertex form, you can kind of just place it into the formula. This gets a little tricky if there's a stretch on the graph. The ones I'm giving you don't have stretches, but if you move on to pre-calculus or like a nasty SAT question in the future, Sometimes there is a stretch in a value other than 1, so that kind of complicates things a bit. But I'm just throwing this out to you because you guys, for right now, if you're watching this in 2020, you're working at home and you have a lot of tools around you that you can help. And if you want to always confirm what you found on a graphing calculator, unless your teacher tells you otherwise, go for it. Go for it, you know. I want you to practice the technique of completing the square, but please do confirm with a graphing calculator if time allows. All right, good luck, everybody. These most definitely require lots of practice. So practice, practice, practice.